Hello everyone, now I'd like to introduce you to a tool called RAX, which is an automated assessment tool for software porting complexity targeting RISC-V. RAX encompasses three main features, which include exploring relevant factors, scanning and collecting tools, and a high-quality porting complexity dataset. First of all, due to the lack of evaluation standards for architecture portability, our tool collects commit information from Git version tools. Researchers with experience in porting and auxiliary tools extract detailed information about architecture code modifications and summarize them by type. Finally, we select the most relevant factors as part of our tool, such as conditional compilation and architecture macros, assembly code, and built-in functions. To improve the accuracy of our tool, we also consider macro factors. Code cyclomatic complexity can help achieve this goal, as there is a significant overlap between code sections that undergo porting modifications and those affected by complexity metrics. It can assess the overall complexity and maintenance difficulty of projects. A complex project often increases the understanding difficulty for developers, implying it may be more heavyweight and have a higher likelihood of being low-layer, thereby posing obstacles to porting effort. Feedback from the community indicates that large projects may require additional iteration testing costs to search for architecture code. Through analysis, we found a strong correlation between cyclomatic complexity and porting complexity. Secondly, we focus on building the scanning tool. We design a system-level cyclomatic complexity calculation method based on McCabe's method and strategies to identify and count conditional compilation and architectural macros, built-in functions, intrinsic system calls, and architecture-related code in build script files. We use information from x86 official documentation to create a keyword recognition dictionary for the above content. Through comparative experiment, we abandoned the idea of simultaneously considering code recognition for multiple architectures, as it may lead to more ambiguous classifications. Lastly, we collect a high-quality dataset by inviting researchers involved in RISC-V porting work to label the data according to four aspects, and set the porting difficulty label for the following training steps. Now let me introduce the components of RAX, including the scanning tool based on architecture-relevant factors, the high-quality dataset constructed by professional score, and the classifier implemented using random forest machine learning model. When it comes to using the tool, the first step is to set up the relevant environment. You can download the RAX package from GitHub and extract it. We provide a requirements file for installing dependency. It's recommended to use Python, as it only requires simple environment configuration to make the tool work. It's extremely user-friendly and convenient. The directory model train and predict contains the classifier and pre-train models, while source scanner include the scanning tool for architectural factors and cyclomatic complexity. Regarding the usage of scanning tool, you need to set the software project's address to be scanned in the mission point .py file as shown in the diagram. Then, in the setting point .py file, set the location where the scan result will be saved. This includes the porting complexity vectors and specific information about the target code location functionality. If you have further requirements, you can customize the tool by changing the addresses of the built-in functions or macro names in the file, or modify the target architecture. The architecture keyword and the function dictionary we currently use are built through official channels. Lastly, set the scanning address for the cyclomatic complexity tool, which can be done in the run configuration. We click lizard.py file to obtain the address information that needs to be set. We should set address of project in mission.py. In setting.py, we set the storage address for the result, vector, and text. For cyclomatic complexity calculation tools, we set the address in run configuration. The RAX tool only requires a relatively short time to complete the scanning tool. Simple projects take 30 seconds to 3 minutes, and complex projects take more than 10 minutes. After completion, checking the corresponding safe directory. This is the porting complexity vector, and also provide target code localization function, displaying all architecture-related codes. In the actual porting process, developers can use this file to query and locate the porting content. Users can easily complete predictions by loading the original model and directly fill the scanned porting complexity vector into the predict.py file to obtain the result. In this example, we use the FreeBSD project. We divide complexity into 3 difficulty levels: low, medium, and high. Based on the evaluation results, we can guide the release development team to allocate resources reasonably and assign developers of different levels to projects of different difficulty levels. We also open datasets, allowing users to add data for training according to their own needs, and complete parameter tuning and training in the model train.py file.